So basically, disclaimer, you've seen all these disclaimers. I'm not going to go through it in great detail because you've seen them. So I'm going to talk a little bit about the geographically dispersed public cloud that we're currently using for our labs. I'm going to do a high-level architecture over the labs, and then we're going to talk a little bit about the vPart architecture, a little bit about VCD, vCenter layout, and then I'm going to move on. And actually, I'm going to focus heavily on the auto-deploy because obviously that's what this session is about. But in order for us to actually do that, what needs to happen is you need to have some kind of context as to some of the reasons why we did what we did. So, want to get that? Somebody get that? Anyway, so for those of you taking the labs, I'm going to make the cameraman actually do a lot of work because he's have to follow me around because I do move quite a bit. Basically, we have effectively 3 sites. As I said, they're globally dispersed. We have one in Amsterdam. We have one in Miami. We also have one here in Vegas. And in this particular diagram, it kind of talks about what we did in 2010, and this is what we expect to do in 2011. We're not quite there yet from a target perspective. I'm not going to spend a lot of time on this, but effectively, links between all 3 facilities. We have a mix-up of, we have white box gear, we have Cisco UCS chassis, we have NetApp filers, we have EMC VNXs, we have Nexenta storage arrays. We also have quad Vs from MDS Supermicro. We have super high density blade servers from Supermicro, which are 20 blade chassis. The switch SuperNAP, if those of you haven't, or anybody take the tour of the switch, anybody take the tour of the switch, you had the ability to take a tour of the SuperNAP switch facility. Very nice facility. One of the things that's really compelling about their facility is that all 120 blades are actually sitting in a single vertical. So we're actually power and cooling 120 blades in a single rack footprint, which is actually quite impressive when you talk about power and cooling. So again, the architecture is such that we have a portal. When you sit down in the lab room, you have this interface that you log into, or the proctors come in, they log you into, and then there's a workflow that actually ties it all together. That workflow was actually written custom by a couple of gentlemen on my team, Claire Roberts and Curtis Pope. They actually wrote the orchestration front end to tie into VCD. One of the big challenges we had this was we actually did a full port of that portal over from Lab Manager into VCD. So you have that portal, then you have basically them load balancing across all 3 locations or into the cloud. When you sit down in a chair, you don't necessarily know which location you're getting. We actually do that kind of load balancing ourselves. So that's something that, again, one of the tenets of the cloud is you guys being clients, you really don't care what storage you're on, what hardware platform you're on. The only thing you really care about is the portal you access and the user experience at the end of the day. Then you've got your core services architecture. As far as core services, we're talking about the apps, the OS, all of those things. Cloud virtualization architecture. Again, all of these are sessions that are available later on today. Each one of those, Claire and Curtis will come in here and talk about the portal. I got Everett and Eric coming in here and talking a little bit more in depth about the architecture. And then I think that's about it, right? So I'm in there somewhere. I think, they didn't even call me out in this slide, so it's, they don't really care about what I do. So real quick, vPod architecture. This is a mock-up of one of the SRM vPods. This was done by me back in the day when we were doing the on-site beta for SRM. We used the same exact underpinnings, and effectively we use this as kind of a template for the worst-case scenario as far as developing an actual vPod. So when you sit down inside of that lab, you're actually logging into a container or a vApp, all right, which is commonly referred to our team as by like a vPod, but it's really truly a vApp in VCD. And as you can see, one of the things I wanted to call out here is the multiple layers of virtualization You have layer 0, which is what we call the physical layer. You have layer 1, which is effectively what we call first-class VMs. And that's where we also have, this is where we start to really bend the space-time continuum. So, geez, sorry about that. So we run what we do. We kind of break all the rules of virtualization because we actually run virtualization and virtualization and virtualization. And where that becomes very important is when you start troubleshooting some of these problems, trying to actually figure out where you are in that stack and understanding where these problems come from and how well they can be magnified. Are they magnified up? Are they magnified down? You know, these are some of the challenges. But anyways, this gives you a good idea of how complex this can actually get. Now, fundamentally, my team, the integration engineering team, was actually formed by virtue of, we originally had a global engineering operations team that basically went out and handled all the VMworld labs. We handled on-site betas, we handled vForums, we handled vMugs. We did all of these things, and over the course of that time, we established some significant relationships inside of engineering because we were kind of twisting up what our product does pretty heavily. And they would really want to get that feedback because we were hitting problems that they wouldn't necessarily see in a general use case. One of the worst environments impossible that you can imagine to apply to an environment is these labs. These labs, you can ask any one of our storage partners, ask any one of our server vendors. We will exercise every layer in the physical stack as well as every layer in the virtual stack heavily. So with the formation of the integration engineering team came about because they realized the value of the feedback of what we're doing here in VMworld Labs. We've had every engineering group in this company walk through the NOC over the course of the last 3 days. All the way from Paul Moritz down to Richard McAniff, Todd Nielsen, every lead, and they want to know what the load profiles, they want to know what the problems are. And that's why our team exists. What we're hoping is that we get ahead of the curve, and before you guys run into the problems in the field, we can do this integrated testing end-to-end, okay, and help kind of smooth out some of the bumps that you guys are feeling by building a wholly separate, wholly clean environment from a net new greenfield perspective, which is what we've done in Switch, Amsterdam, and Miami, okay. We've actually created this environment disconnected from VMware's network completely. We have to establish all of our own management, all of our own DNS, everything from the ground up to keep an operational environment. Now, I told you that to kind of explain this. Now, the super rack is what we call that right there on the right-hand side. That is the 120 node server rack that I was talking about. All right. In the middle, I've got what we call quad Vs. They're basically 4-blade server chassis. Okay, there's 2 of them. We use that for our management cluster for the compute nodes. And then, of course, I've got 6 chassis of 20 blades each. They're dual 6-core Nehalims with 96 gig of RAM apiece. Right? They've got 2 10 gig onboard NICs that we basically use. We loop them up to a rack-based Arista 7100 switch. Those are in turn looped into our core, which is an Arista 7500. Okay, which is all 10 gig, pure 10 gig play here. All right. Now, you'll notice that there's stripes here. These stripes don't actually match to what we're doing in VMworld, but I wanted you to understand this entire rack is deployed with auto deploy and stateless. Okay, we are running 100% stateless in this rack. Now, we have other racks. Okay, we have other sets of gear inside of Switch alone. Okay, I've got an effective amount of basically 9 Gs or 9 verticals, okay, that equate to somewhere around 24 to 28 blades per vertical, depending on whether it's, you know, Cisco UCS or whether it's the actual MDS white box. Yes, sir, you had a question? I do not. I'll get to that. I'll cover that. So here's where auto deploy became very important for us. As you guys might know, you heard me say a little bit earlier that we were actually doing, we're taking a brand new product, and we were porting all of our software over to a brand new product. We rolled through, over the course of the last 3 months, we've rolled through, because remember we're doing this, everything you see in there, by the way, just let me back up just a second. What we have loaded on the super rack, we have a compute nodes, we have management nodes. Remember, we're doing this on ESX 5.0 and vSphere 5.0, something you guys haven't been released yet, okay? We started this 3 months ago. We're doing this on VCD 1.5, again, hasn't been released yet. So we're working with, in some cases, alpha, in some cases, beta quality products. And we literally get builds on an iterative basis. If we run into a Sev1 critical bug, they'll throw us a build to fix it immediately. Well, this is where auto-deploy made us successful, okay? And this is why I wanted to kind of lay out for you why I'm using auto-deploy. All right, and then we'll talk about, I'm going to walk you through the entire process of what auto-deploy is, because I'm doing a lot of air drawings. So I want you guys to take plenty of notes, okay? I don't have a lot of architectural diagrams, because I want you to follow me through these process and walk through that. I'm going to walk through this as we go through it. The purpose of this was that after VMworld, one of our charters is to take iterative builds every 30 days, every 60 days, combine them with all of the other product suites that VMware offers, and start banging the hell out of them, right? What we call that is going to be a use case portal sitting in front, whether it's we serve up labs to individuals inside of VMware, whether they go public with them, I don't know, right? At a certain point, we'll develop new use case portals. Eventually, we'll hand those off to some operational unit that will basically support those in an ongoing fashion. But we will basically want to generate load. Now, like as I said, 480 lab stations, okay, sitting out there right now full, with approximately 5,500 operational VMs being torn down and built in an hour. Every hour. It's one of the worst case load you can imagine. Nested storage, nested ESX, all of these things pretty much beating the hell out of the environment. So I needed to have a plan to basically be able to what I call ebb and flow this environment. Certain test cases. I may want to have 120 blades divided up into 4 clusters, right? Or I may want to have a smaller subset. And so that's what that's where those G's come into play. Right? We call them the G's. Everybody's referring to as the G's now. The G's inside a switch, a G2 through G10, right? In this particular environment, okay, I have 5 G's of 24 blades apiece. Right? Those blades, as I said, are all booted with auto-deploy. These stripes basically indicate a G vertical. The vertical stripes across all chassis. Right? And one of the reasons why I wanted to do that is I wanted to be able to not basically isolate myself to one chassis, so we could do things like simulate chassis failures, simulate blade failures, simulate, kind of go wide, as I said, ebb and flow, ebb and flow. And then when we started talking about this, remember, we're talking about the cloud. We're talking about the potential of having somebody being in there as a tenant. And I wanted to start at the lowest common denominator, what I felt based on certain mathematical properties we needed to basically provide to this whole contained environment from a VLAN perspective. Right? So we basically went down to the base and we said, let's talk about X number of VMs per processor, how much we think memory, kind of do kind of a swag, and figure out, tier 1, tier 2, tier 3 applications, and stack them together and come up with a figure of how many customers we believe can hit every blade. And that's what we did, and then we pushed that up. So we're presenting up right now to each environment 800 VLANs. We're also presenting up core. We split out basically our management network. Now this is where you guys got to start paying attention. Our management network is all one flat VLAN. It's on the native. Basically that's our native VLAN. We use that to boot all of our ESX hosts. Okay? We also have storage networks for each of the vendors, for Nexenta, EMC, NetApp. We have an FTV motion network, separate VLAN. We also have a tenant net, which is basically that band of IP addresses that will allow tenants, so we can actually use those for VCD if we want to basically assign a specific VLAN or tie it into an actual internet link or whatever, allows us to do that as well. Plus we have various other VLANs in there. So effectively 800 plus VLANs. All of our management hosts are separate. They're a separate management cluster. I run in there my VC, my auto-deploy servers, View. I run all of the components that I consider to be supportive of the actual management clusters, of the compute clusters themselves. And I'll talk a little bit about that. Okay? So, the upshot is, today, right now, if I want to change the software on 120 blades, meaning the entire ESX build, plus the VIBs for VCD, we'll talk about VIBs in a minute. If I want to do that, it takes me an hour from start to finish. From boot to back online, 120 blades, I can change every ESX build with all the new VIBs in an hour. Okay? So let's talk about the components involved in auto-deploy. How many here are doing Pixie boot? How many here are doing Pixie boot to multiple devices in the same environment? How many turn off their Pixie servers as soon as they're done? Okay, so yeah. So there's multiple challenges involved with obviously Pixie booting. We all know them. We've all dealt with them. Pixie booting in a VLAN environment is even more challenging. So one of the things you have to understand is each one of these Gs that you see up here represents a virtual center instance. Right? First thing you need to know about auto-deploy is a one-for-one relationship. For every auto-deploy server, I need a VC. It's not many VCs to one auto-deploy. It's not many auto-deploys to one VC. It is a one-to-one relationship. Okay? Well, right there, I've just inserted a problem for myself. Because I have a flat VLAN, all my ESX hosts boot, and now I have to effectively boot all 5 verticals, right, on the flat VLAN into 5 separate auto-deploy servers, or effectively 5 separate Pixie environments. Okay? So we had to overcome that problem. Our IPAM DNS software solution right now is we're using Infoblox. Okay? And they have a very robust grid-like environment, and working with them to actually work through some of these issues. But for a stopgap measure, I picked up an actual Pixie server that allowed me to do what was called virtual folder redirection. In which case, you go up, the first step is you go up to your DHCP, right, and you basically establish the DHCP rules that you need to establish. Okay, where do I want to boot from? What's my Pixie redirect? So what server is he going to? People call it the next server option or whatever. Okay? And then what file do I want to use once I get to that server? Well, as I said, everybody's booting off the same network. They're all getting the same information from the DHCP server, right? So it redirects it to this TFTP server. TFTP server says, what's your IP address coming inbound? And based on its IP address, it's assigned to a specific folder that has its specific boot binaries in, and everything else happens magically. Okay? Now it's kind of a real quick run through of what you need to do. So, let's back up a little bit. Let's get to the installation. The installation of auto-deploy is on the actual Vim setup CD. Okay? What do you need? You need the binaries for auto-deploy. Okay? You need to establish where you want to install it. There's 2 different types of auto-deploy. There's 2 different types of virtual center. Virtual center, that's the appliance. Okay? Auto-deploy comes packaged with that appliance. If you want to use the Linux version, you can. Windows, it comes packaged on the Vim setup CD, and you can either install it co-located with the virtual center, or you can establish a separate server. I prefer to do the separate server thing. I need more load on my virtual center like I need a hole in the head. Okay? So we basically have it separate. The next thing you need to have is Power CLI. You have to have Power CLI. This is how you're going to manipulate what your auto-deploy server does, can and cannot do, will and will not allow to happen. All right? Now, there was a decision made in engineering based on time available, based on the amount of threads that they had left as far as developing this product. We want to get the product out that's working, or we want to get a product out, that has all the interface doodads, but it's not working as well. So they made the conscious decision to focus on the underpinnings to make sure that it was solid and resilient, and they're going to actually focus on the actual interface pieces later on. So it was a non-trivial task when I started working with auto-deploy. I'll be honest with you, it was non-trivial. It took me 2 weeks to get to a point where I wasn't working. So I went to engineering and I said, I don't understand. This is a fairly simple concept to me. Why is this not working? And the response I got was, you didn't read the manual. So I said, okay. I did read the manual. If that's the way we want to go with this, that's fine. If there's nothing operationally wrong with this, then great. So we rewrote the manual. We put in this thing in this section, and you'll see it. You'll actually see it. They use it. They've leveraged it in the labs for auto-deploy. But there's a proof of concept set inside of the document that takes it from a greenfield, ground zero state, assuming you have nothing other than ESX and Virtual Center. Assuming you have nothing, and it takes you from that to an actual operationally running environment. Now, I didn't say production, I said operational, okay? Because I want you guys to be able to go out there, build an auto-deploy server, and use it and kick the tires on it, understand how it works. Then you have to worry about the next step, which is operationalizing it. So, the reason why I call that out is because you are now reliant on services that were historically Tier 3 that you now need to move into your Tier 1 service. Pixie is a great example, right? I Pixie boot a laptop, I do the install of the OS, no problem, right? I can let that thing go away, the laptop works. Now, you're putting your ESX hosts onto a Pixie server that the only way they can boot is if that thing's online. So rule number 1, Pixie service does not exist inside the compute nodes that you're Pixie booting. Okay? And it's common sense. Right? This is where we get into the debate about should I have a management cluster, should I not have a management cluster. I've always been of the mindset you should have a management cluster. I've always been of the mindset that you should not statelessly boot today your management cluster. Later on down the road, I'm sure that we'll come up with some creative ways to get around some of the inherent problems with that, but right now, management cluster doesn't Pixie stateless. Compute nodes, absolutely. All right? So, I kind of talked about the components. You got to have PowerShell. Got to have it. That's what you use to manage it. You got to have the binaries to install auto-deploy. You got to have a VC. And you have to have host profiles. Okay? It is required. That's how the rest of the magic occurs. So let's walk through the process of what happens. I turn on an ESX host, reaches out to the DHCP server, and gets an IP address. Stop. DHCP. DHCP reservations are your friend. DHCP reservations are absolutely your friend in this environment. Okay? I've set up all 120 hosts, static DNS entries, static DHCP reservations. Right? And I'll talk a little bit more about that going forward. But you may have heard me talk to you about I've got separate VLANs for my storage, which means a VM kernel port, for every separate storage, for FT. Okay? All of these things we're going to come back to. But you have to have, I personally think it's a requirement. You guys can do it without it, but I'll tell you where the challenges come in a little bit later. So now I've got my IP address from DHCP. I've put my rules up in the DHCP server. It says, hey, point to that TFTP server, okay, and use that file. Stop. TFTP server. Remember I was telling you, I've got a custom THCP server available out there. You'll see it. It does virtual folder redirection, which basically says any IP address in this range or any IP address based on this list can access this folder. So remember, it's already got an IP address from the DHCP server, and that's what it's reporting when it gets to the TFTP server. Now he's allowed to access a specific folder. Well, how did that stuff get in there? All right, good. So we're going to stop there. When we did the install of TFTP, when we did the install of auto-deploy, it asks me a couple questions. What VC am I talking to? Where's my auto-deploy repository going to be? Repository is where I hold my software depots, and I'll talk about that in just a second. Okay? And at the time when I did the install, I go into the Virtual Center interface, and there's a big green arrow that basically says auto-deploy. I click on that, it takes me to a page, and it says download TFTP binaries. What it's basically saying is, this is what binaries you're going to use to boot. It's basically a package of files you copy into your TFTP root folder or into your virtual folder that you're redirecting to. You copy those in, you blow those out, and it has all the boot files needed to actually boot the initial bootstrap when auto-deploy requests it. Okay? So fast forward. Back in my TFTP server. Request came in, I've redirected it to a virtual folder. It says, give me this file. The ESX host does just like a normal Pixie boot, right? But in that file, there's also this thing called the tramp file. The tramp file basically says, now that I've booted my mini kernel, where do you go to get the rest of the information that you need? And in that tramp file is held the IP address and the HTTP address of the auto-deploy server. So then it reaches out to the auto-deploy server and pulls down whatever it's allowed to pull down from a boot perspective. Stop. Okay. Sounds pretty simple, right? So far, standard Pixie, right? Everything's cool. It's booting, it's getting a mini kernel, it's being redirected to where it's supposed to pull its binaries down. Okay? How did those binaries get there? This is where Power CLI comes in. Okay? Power CLI. Okay? Do the setup Power CLI. If you haven't gotten Power CLI, you gotta get it, use it, be familiar with it. Great tool. But all the commands that you need to manipulate this environment are basically included with the Power CLI binaries that are shipped or going to be shipped with 5.0. And in there, we have this tool called Image Builder, Image Factory, whatever the name will be when it comes out, but it's related to images. And we say images, we mean ESXi stateless images. Term number one. Software depot. ESX software depot. A software depot is a grouping of VIBs. Okay? VIBs are effectively software packages. Okay? Now, some of you may use them today. Dell may give you a VIB to install for its open managed stuff. Right? HP may give you a VIB for its drivers. Cisco may give you a VIB so they can have the actual hardware links, so on and so forth. Okay? Well, remember, this is stateless. Today, in today's world, you can push a VIB down and it'll actually stick because you have installed, stateful, installed ESX kernel. And you can push VIBs into it and it'll stay there on a reboot. Inside of ESXi stateless, you have to include it as part of the boot packages or the boot binaries. This is where Image Builder, Image Factory comes in. Software depot. Every time you fire up a Power CLI session, you have to basically indicate what you're using as a software depot, because it needs to know what it's going to reference from a file perspective. And they'll send you something that says, you know, open managed Dell whatever version number .depot tar.gz. And you'll point your Power CLI session to that. You'll point your Power CLI session to the ESXi software depot, which has all your basic software in it. All the things you need to actually boot an ESX host. Once you've allowed auto-deploy in that Power CLI session to see those things, you can now manipulate your boot environment, what you want to boot. Images, that's the first thing. Second thing, write this down, there are rules. Okay? There are rules that you establish to determine how you want to boot this ESXi host. Okay? The rules consist of a couple of things. Patterns and items and images. Okay? What you're saying is, I want to boot an image based on these rules, and I want to apply these items to it. So let's talk a little bit about patterns. A pattern can be a MAC address list, comma separated. It can be a range of IP addresses that are coming into it. It can be a UUID of a host. It can be an actual type of host, HP, vendor type. It can be HP, Dell, UCS, whatever. That can be part of your pattern. Okay? Item list is the what, right? You've just specified who, now you're going to specify what. What image do I actually want to use? Okay? What do I want to actually, where do I want to put it in the inventory? Right? Is it in cluster 01? Is it in cluster 02? Where do I want to put this? And the third thing is going to be, wow, just blanked out for a minute. Ooh, rough night. So we've got, the host profile. Which host profile do you want to use to actually configure this host? Okay? So you create this rule. The first rule that I typically create when I go in here and I build this is everybody boot to this image. Okay? And I'll tell you why in just a second. But everybody use this image to boot. All right? And then I'll go and I'll create a more specific rule that says, hey, listen, UIP addresses from .75 up to .100 are all going to boot to this image. You're going to add yourself to this cluster, and you're going to use this host profile to configure yourself. Okay? So, where were we? Where did we back up when I stopped and jumped in? I booted to an image, right? Now that I've booted to this image, based on the rules that I've just defined, okay, it attaches itself to the sister VC instance, adds itself to inventory, wherever we specified in our rule, adds itself, goes out to the host profiles, and the host profile that we indicated as its master host profile will then be applied. Stop. All right. Problem is, I have already answered one question, which is VM kernel 0. VMK 0, my management network, it knows what its IP address is because it's getting it from DHCP. Anybody care to hazard a guess how it's going to get its information regarding all of the other 4 VLANs that I just installed on it? Answer file. That's right. It's a new thing in 5.0. There's an answer file that basically says anything that is host specific needs to be answered prior to applying a host profile. Okay? Then of course, VM kernel 1, VMK 1, 2, 3, 4, things like specific host root passwords, specific actually tying it into an actual domain or Active Directory domain, administrator privileges to do all that. All of those things are in an answer file now. Okay? So what will happen is, in this case, because I've gone in and this host is just coming online for the first time, there is no answer file for it. So I have to establish an answer file. All right? Now, engineering, when I basically told them I needed to do this 120 times, I told them that was going to take me a little bit too long. So they basically wrote me a script that will actually go in and pre-populate the actual ESX host in my inventory. All right? It'll actually associate the MAC address as a unique identifier inside of VC. All right? And then it will actually allow me to create this shell of an answer file with the answers already in it. So that when I power on that new ESX host, and it comes into that cluster, and it sees that MAC address as its UUID, because remember, you can't have, a MOREF or a UUID for the ESX host because it hasn't been added to inventory yet. We just spoofed it. So that's what I did, and of course it was a really monumental, it was really a pain. Okay. It was really a pain to really develop that script, because if I changed anything, I would have to redo that script that required a local answer file. So, but anyways, they made it, they worked. Now that answer file is there, I've got ghost hosts sitting in my inventory, and every time these come online appropriately, right, with the ghost, this is initial boot, by the way. All right. They come online, they attach to the appropriate host profile, they do what they need to do, they got their answer files. Okay? So, host profile, answer file is applied, it modifies whatever settings are required in the host profile. The ESX host is now online, in your inventory, ready to go, in its cluster, compliant with your host profile. Sounds pretty easy. Okay? It is, for the most part. Like I said, once you get used to doing the commands, it's actually pretty easy. The problems are as follows. Problem number one was getting around the whole answer file thing. Now, interestingly enough, they've added another feature in 5.0 on the host profiles part where you can enable and disable certain components of that profile to actually be able to solve some of these problems, like Active Directory authentication, where you have to enter it won't save credentials in the host profile for authentication. You have to type them in every time if you want to do an answer file. It won't save them in the core profile. So you can enable that or disable that. I don't want it to check. Right? So there's certain things that you can do and can disable as far as the host profiles and what it checks. So where are we? We've now got a host that's booted in. So let me walk you through what you need to do, start to finish. Now you know the whole process, right? Does everybody understand? Any questions on that? Yes, sir. That's probably going to be something you're going to have to configure. I don't know what the integration with any of the third-party vendors as far as being in the answer file. So far, it's all host-specific as related to just getting the host online. All right? So I don't know about the PowerPath thing. My guess is the VIB will be configured in some manner or fashion when you add it to that. Again, there's a lot of questions, in certain circumstances, ESXi stateless, what our partners are going to do about certain things. No? Any other questions? Yes, sir.
How do you deal with different
Good question. That's how I dealt with it, was with DHCP reservations. Again, this is why I said to you, some of those things are very important. Right? I personally think we should have made it a requirement, but the engineering department didn't want to limit you guys. We wanted to give you lots of rope to hang yourself with. I think it should be. I think it should be a requirement. Matter of fact, the truth of the matter is, you could potentially do DHCP reservations for the other components in your networking stack. Problem is we're talking about, in our environment, all of these are using VDS. So when I build a VDS inside a VC, and then I add a virtual NIC or a VMK NIC, they call it a virtual host adapter, right? The problem is I don't know what its MAC address is going to be because it's generated by VMware, right? So I can define it if I do it once, add it for every host. But I don't want to do that, right? I just want to answer a file. Now, here's where you're going to start getting screwed up in your own environment. Well, actually, let's back up. Let's walk through the process of what you need to do. You go home, all right? You find a VC instance, 5.0. You find a couple of boxes you want to do auto-deploy on, okay? You basically go in, you set up, the first thing you do is you open up a Power CLI session and you establish your software depot. Say, this is my software depot, okay? Then you're going to create a rule, a base rule that says, I want all my hosts to boot to this image, period, right? Everything. Auto-deploy, you install, auto-deploy, do all that, right? You have to have that all installed. I'm assuming you went through the clicky-click process doing the install, downloading to the Tftp server, putting your DHCP options inside of your DHCP servers, or redirecting to your TF. All those things I'm kind of assuming. You can go through the POC doc. We specify this out pretty good. So you do your rules. You type your rules in. Every host comes up and boots into this rule. Adds itself to VC at the highest level, adds it right to the data center because you haven't specified otherwise. Okay? Stops it at basically maintenance mode. Anybody tell me why it would stop at maintenance mode? Anyone? No? Has no answer file. Has no host profile, no answer file. It doesn't know what to do. So it'll stop there at maintenance mode. That's key indicator one for you. If you have an auto-deploy environment that you think you've set up appropriately and that host comes up into maintenance mode, there's something wrong with either your answer file, it's not getting a host profile, all right? That's indicator number one. Check your rules, make sure everything's cool, right? So the reason why it has you boot all your hosts up, okay, is because it sudo adds them into the inventory, like I said, under the data center. Now you have to build your gold master host profile, all right? So you basically choose whatever host, whether it's host 1, whatever. Choose that host, and you configure it the way that you want it. Now, there's a couple ways you can do this. You can manually go in, type everything in, take a Power CLI script, which is my preferred method, by the way. I take a Power CLI script and I basically configure all the network interfaces that I want on it. I get it added to the domain. I give it all of the passwords that I want it to have. I set my NTP services. I set my NFS TCP settings, my advanced settings for NFS. Okay? All of that stuff I do. Then I go create host profile from that host. All right? It goes out and creates my ESXi gold profile. Bam. It's there. Then I take that profile and I associate it to my cluster. All right, cluster, here you go. You're using this host profile for everything. All right? Now I've got this pristine host, good to go. Now what do I need to do? Well, I need to basically establish a couple of things. I either need to go in and create an answer file manually, or I could have, I don't know if this tool is even going to be made available to you guys out the gate. It's wicked complex. I mean, I can tell you right now, I spent a week configuring that pre-deploy script to try to get it right. Because it's actually going in and manipulating, down at the .vim software layer, different fields, and it's not like you can do a command line command to create this answer file. But, anyways, so now you're going to go in, now that you've associated all your hosts, you're going to see this thing in there. It's a new feature. You can check to see whether or not your answer file is complete based on the current host profile that's pointed at that host. You can update that answer file, right? You can apply your ESX profile, so on and so forth. The first thing you're going to have to do is make sure that your answer file is complete for every single one of those hosts that are in the list that you want the host profile to be applied to. Once that answer file is complete, you can literally bounce those hosts, have them come back up, and they will be configured appropriately for auto deploy. It's that simple. Now, again, one of the reasons why we're using auto deploy is because I needed the ability to rapidly change the builds, the VIBs, and all that stuff, right? Well, I also knew that I had X number of ESX hosts. These all didn't come all online at once because I'm doing all the work by myself, right? So what I would do is I would build a set, and then I would bring them online. Well, I pre-populated my scripts that actually did the pre-population of the ESX host in VC, created a spreadsheet, basically pulled all the information out of the spreadsheet, and I can run those against my individual VCs to pre-answer the files, associate MAC addresses, the whole 9 yards. We lost a VC because of a database corruption issue that was caused by me earlier this week. And what I had to do was I had to basically go in and change the redirect and change the rule down on the actual auto deploy server. So what happened was one of my verticals lost its VC. I needed to get those hosts back into production as soon as possible. Didn't have a lot of time to rebuild VC. What I wanted to do was just redirect those so that they were added into other clusters on the other G verticals. I made 2 changes. Change number 1 was I changed, remember the virtual folder redirect that I have in my TFTP server? I basically said, take all these IP addresses and put them in this now into this folder. Then I had to go into Power CLI, had to add my software depots in, make sure that I'm good to go there, and I modified the deploy rule to basically say all IP addresses from this and this now are appropriately allowed to boot into auto deploy. At which point, they booted in, they came up in maintenance mode. Well, why did they do that? Well, because the profile is sitting over on VC. Okay? Now, I'd like to tell you that it was as simple as basically just plug and play, but because I'm using a pure VDS environment, there was crap left over from the previous install of VDS. thought it had a DBS, but it wasn't in sync with what Virtual Center thought it had. Okay? So I had to go ahead and do some add and removes. But effectively, an hour later, all my hosts were rebooting into another VC, doing the things that they needed to do. Okay? 2 changes. In this particular architecture, there was 2 changes that needed to be made. The range that was allowed to boot to the TFTP folder, and the range in the actual auto-deploy rule. And that was it. Okay? So, let's see. Challenges. Some of the rules, some of the building of rules, some of the what we call rule set compliance. If you make a change to a running ESXi stateless host, let's say you change the build number or you change the VIB, you have to do this thing called test rule set compliance. Okay? Now, what it does is it goes and looks at that host that's booted online and says, hey, I'm booted to this package with these VIBs, and you asked me to boot to this package to these VIBs, and it'll basically tell you whether it's compliant or not. You'll say no. Then you have to do this thing called repair rule set compliance, where you basically pipe that test into a repair, and it'll basically fix for whatever you need to do. Now, a couple things to note. If you change the image, okay, you will require a reboot when you do the repair rule set compliance. It won't do it for you. Okay? It won't shut down the box when you do a repair. It just repairs the rules and the association inside of auto-deploy to be right. Then you reboot the host and it comes back up and it boots into that image that you specified. Now, if you were to change something like it's sitting in the data center, but I want to move it into a cluster because I've now added that cluster, okay, it will do that on the fly when you do a repair rule set compliance. It'll push it right into that cluster for you. Same thing with like applying a host profile. Right? If I say, you know what, I'm going to change the host profile at the rule, do the test rule set compliance, repair rule set compliance, and it'll push it right in and give it apply the right profile. So at the early stages, that was a little weird to me. Right? I didn't break it. I didn't think that I broke anything. I wanted to modify that, or I wanted to make sure that I wanted to update. Repair struck me as being a bad term. But understand, repair and test, okay, what they're saying is you made a change, you want to update it, right? Rule set compliance. Software depots, you can add and remove software by running commands, so you can add VIBs and remove VIBs. At some point, I would hope that we'll be able to give you a tool that will determine what VIBs are actually being used so that you can strip down that image to as small a size as possible. Smaller the image, the faster the boot. Right? The other thing that right now that they're potentially, we're gonna stay away from right now, but there is an option where you can basically take out the VMware tools. Instead of feeding that VMware tools package on boot, it redirects to a centralized data store or LUN or service where your tools are stored. So that way, every time you boot your host, it's not streaming the tools package. Quite frankly, the tools package is the largest VIB in that boot package. So there's at some point going to be the ability to say, my tools are here in this directory. You don't have to load them on every boot. All right. Let's see. I'm trying to think if there's anything else. It really was. Again, follow the proof of concept doc. When you get it's actually in the core documentation. I helped write it. I know it's there. It takes you again from 0 to boot. So once you've established your answer file and all that, you can go in, reboot your other hosts, and do all that stuff. All right. Outside of that, I'm going to take some questions if anybody's got any. Yes, sir. You pointed to the TFTP server's IP address. I do in the actual boot file name. Right, so there's the actual TFTP server itself, the boot file name. Let the TFTP server itself handle the folder redirects. Okay? They're all going to the same TFTP server. Only a subset of them are going to each individual folder. Okay? Yes, sir. Yes, and it's a good question. So for software depots, you can pull them off. So one of the things you need to understand, when you create that initial rule saying I want to boot to this image, if those binaries are not uploaded, they will upload at that moment to the auto-deploy repository, wherever that is. Okay? And it can be a shared folder. Bear in mind, if that folder is not available at the time when you boot, you don't boot. Right? So these are kind of concepts. While you think it's kind of silly for me to say that, the fact of the matter is nobody's looked at PXE as being a mission-critical application. Just like potentially storing a bunch of binaries for PXE hasn't been a mission-critical application until now. Statelessly booting, you put them on a shared folder all day long. Matter of fact, I have a shared folder where all my auto-deploy scripts are and all my deployment scripts and all that. I keep them all in a shared folder. All right? But you absolutely want to make sure that that's resilient. Another question? Yes, sir. Right now, if it goes offline and my host doesn't boot, something's wrong. You know that sounds stupid, right? But I literally can't find a vendor that has a high availability DHCP well, actually not DHCP, but TFTP service that has the virtual folder redirect capability. Hence the reason why I said I was working with Infoblocks. Infoblocks was interesting to us because A, we're working with them at VMware already for whatever reason, and then the other reason why is because they have this thing called the grid, where they run global services on multiple grids, and we have grid. The grid is established through all three sites for us. It's like Active Directory, right? It's always kind of there, and they're talking to each other, and if one doesn't respond, it'll go to the other one. They're doing the same thing with their TFTP service. The only problem is it doesn't have the virtual folders. So as a stopgap measure, I have a piece of software that we just kind of make sure that it's up and it's there, right? I go into it on a regular basis. I've got a developer buddy of mine that works on my team that could probably write some sort of monitoring script to actually go in and ping it, and actually give me feedback as to whether or not the service is there, do a hello, check, ACNAC, whatever you want to call it. But yeah, finding one of those because effectively up until recently, TFTP was it didn't matter, right? Now it matters. It absolutely is. So we could absolutely do that. But again, that doesn't solve the problem. Remember, fault tolerance solves a virtual machine from falling over on itself, right? I could use HA as well, right? In general, cause it, but that doesn't. If the service itself dies, I still have a problem, right? But yes, it is fault tolerant. One of the things about auto deploy that I didn't talk about, sizing. Your mileage may vary. Okay, and depending on how many hosts you're pushing out, how many you want to simultaneously boot, how much CPU is required. Again, I want them separate personally. I don't want to co-locate them on a virtual center. And the reason why I don't is we remember what the process was, right? I boot to an auto deploy server, it streams binaries down, it then reattaches itself to VC. Host profiles have to apply a bunch of hosts. It's busy adding things in and out in maintenance mode and all this other stuff. If those things are all happening simultaneously on your VC box, in my opinion, it's an unnecessary load. Again, your mileage may vary. Yes?
You made a comment about ESXi, other deployment management cluster.
I did not make any comment about future features or anything along that line. And if you...
As far as doing this, if you're doing decentralized
Yeah, so you're absolutely right. It's a thing that... What I said about the future, just to be clear, what I said about the future is something we were going to have to solve. We have to figure that out. Because I believe, personally, that the future of ESX is going to be stateless. Okay? Somebody asked me the question the other day when I was doing this, with a UCS chassis, isn't that kind of, they're like, wow, with the capability of the UCS chassis and auto deploy, isn't that like redundant functionality? My argument is they're very complementary. They're extremely complementary. And the reason why they're extremely complementary is because if I lose a blade in the UCS chassis, I rip it out, the server profiles push their MAC addresses right back to it. I don't have to change anything. Boots right back up, comes right back up, reconfigures that host, and everything's good to go. So so there's one thing I did want to tell you. When you guys go through this, and this is going to matter for all host profiles in 5.0, by the way, so you might as well just pay attention to this, because all y'all are going to have this problem anyways. One of the things that it does that drives me absolutely insane is every time you go and update from a host, you make a modification to a single host, that is the host that you applied your host profile for, you built it out of, and you say update from host, it basically sets all of your settings back to what they initially were. It literally takes everything on the host, pushes it back over. It's effectively like recreating a new host profile, okay? One of the things that drives me nuts about that is I want all my ESX hosts to have the same administrator password, okay? So I basically you have to go into the host profile and modify the host profile to say, have all of my hosts have the same root password or administrator password is what they call it. Every time you update from host, it'll revert those settings to basically say leave the password unchanged. Okay, it's one thing, kind of drives me nuts. The second thing is that it reverts the actual enable disable profile configuration stuff that you've established, right? So you have to go back in and set those again. Where you're going to run into problems, okay, is when you build these things. If say you have VM kernel IP addresses and whatnot, the only one you want to basically specify the MAC address is the VMK0 interface, the management network. And it's going to derive that from whatever MAC address it pixie booted from. The rest of them need to be set to user explicitly chooses policy option. Otherwise, it's going to ask you for a MAC address that you don't have because it's virtual. Okay? Now, again, like I said, I don't care what the placement is. Okay? I don't care if it puts it on Mac, whatever. It doesn't matter to me, as long as it puts it on the VDS appropriately. The other thing that drives me absolutely bonkers about the new host profiles is, in this case, remember, the default for a host is to come up with at least one VM NIC attached to one vSwitch, which is a standard vSwitch. In which case, we then go and we build virtual distributed switches underneath the covers as part of the host profiles. If you decide you want to leave vSwitch 0 there, but you want to add a VM NIC to it, so you keep management net down on vSwitch 0. Now, there's some benefits to that, and I can talk to you a little bit about that in just a second. But you leave vSwitch 0 there, and you build out your VDS, and you add your VM kernel ports on the VDS. As part of the host profile, to get that second NIC on there, it removes the vSwitch and rebuilds it and adds two vNICs onto it, which drives me nuts, because effectively, if you have any settings in there that indicate a specific MAC address or something is set wrong, it will fail, and then all of a sudden you don't have management network anymore. Drives me nuts, because yes, sir. They're going to be part of the release notes, from what I was told. Always, you guys know the rules, right? I mean, some of you have seen me talk before. I know Verge has up back there. I always tell you the rules of engagement are as thus. Okay, the first point of contact you make is you call Dr. Google, and you type in a question to Dr. Google, and you ask him, "What the hell is going on? I'm seeing this error." 99% of the time, it's in there. Right? The next thing I tell you to do is go do what you should have done before, which is read the doc, read the release notes. Okay? The release notes are actually more important, in my opinion, than the actual document. Because if you read the document, you think you know what you're doing, and then you change something in the release notes. So anyways, release notes, Google, documents, forums, you're going to answer 99.99% of the problems out there that you run into. Yeah, you had another question? I'll tell you what, they've done one hell of a lot of work on host profiles. I was actually surprised at the amount of power and the level of complexity that they've actually put into the host profiles. They've put in so much. You can absolutely screw yourself 7 ways to Sunday now in your host profiles. Okay, we've made them wicked powerful so you can be, wicked crazy and do all sorts of stuff. One of the big problems I had was it was annoying as hell. I couldn't get any of my hosts to come compliant. They was like, well, what the hell's going on? Well, I had local drives at one point in my host profile. So all the local, but I'm not using local drives because I'm booting stateless. So I don't really care whether or not their SATA drives are online and they're doing PSP and all this other stuff. I don't care about load balancing. They're not being used. Enable, disable profile configuration. I can uncheck everything other than NFS that I want to check for as far as profile configuration, and I no longer show non-compliant because I'm not using those capabilities and it doesn't matter, right? So there's a hell of a lot of features and capabilities you can do in these host profiles. Yes, sir?
How do you deal with configuring the BIOS?
Well, I push that off on my vendor. I say, you know what? As part of my SLA, when you send me a server, or when I buy a server, I pay that extra dollar figure in order to make sure that the BIOS settings are exactly the way that I want them. And then if I can't get that done and somebody doesn't want to pay for that, then I basically tell them to come in and do it because we're VMware and we can punch them in the head if they don't like it. I'm just kidding. Well, not really. But no, so it's a manual process. Unless they have the ability to script down to their CMM, some of them do, some of them don't. Those are all standard issue problems. To me, auto deploy is going to be your future. I mean, I personally believe that you're going to want to use this. It's not a matter of why should I use it? It should be obvious to all of you. I could potentially have, once we get through some of these scripting issues with the answer files, and because that's a big, to me, that's what I'm going back to engineering with. After VMworld's over, I'm going back to them and I'm saying, here's what pained me the most about this, right? Clicking through the process of clicking through 15 times on an answer file is ridiculous. Doing it 120 times is even more ridiculous, right? So we got to fix that, in my opinion. So I'll go back to engineering and say, you know what, iteration 2 should absolutely have these UI features or these capabilities, whether it's scripted or otherwise. Throw me. So now if you think about that, when we get to that point, if you know that in the next 6 to 10 months you've got X number of hosts coming and you're getting a bill of materials from HP, you can have all your stuff pre-deployed, ready to go, sitting there, rules, everything. MAC address defined, all of your DHCP reservations already in place, and you just slap in that blade into the cluster, it comes online to the network, and it automatically gets booted into what you want it to be booted in, and it's configured automatically. That's elastic. That's what that's about. That's the elasticity in a data center. Now all of a sudden, if I know, and I can get HP to define what they are, or even if you're going to do a rollout and you're going to have them sitting in a cage for 6 to 8 to 10 months or whatever, and you got these spares sitting here, you already know what those numbers are. It's fairly easy. Or, even better, if you got something similar to a UCS chassis, where you define the MAC addresses and you define all of that information, right? That's even better. But this is the future, in my opinion. And VMware is going to spend, because I'm going to yell at them, they're going to spend a lot of time focusing on auto deploy. Any other questions? Yes, sir. For which? I don't have enough time to actually go into my monitoring strategy because I'm actually still building my monitoring strategy. Again, we built a data center in 3 locations, 3 data centers with a little over 300-something nodes over the course of the last 3 months. My strategy is still evolving. Right? I have logging servers. Okay, I have management and monitoring. I've got VC Ops running. Remember, we're a VMware first shop. Go figure. What we do is we take every product that we have. Part of our charter is to figure out where the gaps are. Do I fill them with software from somebody else? Do I fill them with custom written software or scripts? Or do I actually go out and acquire a company to actually fill that gap? That's part of our job. So that's why I kind of gave you a mealy answer on that one, because we still haven't figured out exactly what gaps we're going to miss, what we need to actually fill in. I saw one other question over here. Yes, sir. How many VCs do you have? You have 30 virtual center instances? Yeah, you're gonna need to folder redirect stuff. If they're all in the same, if your ESX hosts are all booting from the same subnet, yeah, you're gonna need to figure out the virtual folder and figure out that. It's WinAgents. Excuse me. WinAgents actually is the name of the TFTP server. We bought it. It's like $300 or something, but it's not designed to be resilient. There's no automatic services. Again, to his point, you can use FT on it if you really wanted to. It doesn't have to be that powerful, right? It's a TFTP server. The virtual folder thing was very key, but I would absolutely, in your case, if you had that many VCs and they're all in the flat, if they're all booting from the same network, then yeah, absolutely. If they're booting from if they're on separate VLANs, you can still have. You can have your 10 TFTP servers. You can do the router redirect option, so on and so forth. 5 minutes now? I'm done? I'm finished? All right, one last question and then yes sir. Upgrade of the auto deploy. Well, seeing as how this is the first iteration, I hadn't had a chance to upgrade it yet. No, I don't believe you will. I mean, all that stuff is actually kind of stored in the database with Virtual Center and auto deploy, so you shouldn't lose anything. Thank you, folks. I appreciate you coming. Guys, fill out your surveys. See you later.